Podcast number 49. We must be about halfway done. So when it's sine and cosine, I would usually use 0 to 2 pi. But there is something interesting that happens with this graph. So let's take a look at the graph first and then do the derivative. With this 2t on the cosine, that means that to get the full cycle, you actually only have to use from 0 to pi. So what happens if we only use 0 to pi? So here is the function. There's the x part, the y part, the cosine is being squared. And then if you go from 0 to just pi, and I'm going to slow it down so the t step is going to be small, which on this app on the iPad, it just draws the whole thing. On the calculator, you'll actually see it draw. And it's going to start from right there is when t equals 0. It's then going to go like this, and down here is where a derivative will equal 0. That looks like it's pi over 4 or so. And then it's going to continue up here. It's going to reach this little top point, and that looks like it's pi over 2. It's then going to have to go down, and then it's going to draw the left side. So if I go back to the window and now have it go from 0 to 2 pi, you could then see it's sort of like a W-ish. So it starts here, goes over to this sharp point, then has to turn around, go back, trace the rest of it. Here's another place where the derivative equals 0. And then by the time it gets to 2 pi, actually it gets to this point and then comes back until it gets to 2 pi. So it basically has to retrace itself. Okay, so that's the graph. Then what about the derivatives? So first of all, the dx dt equals 0. So the derivative of the x function, that is just cosine, and then set it equal to 0. And it's saying, when does cosine equal 0? So if you go back to basic trigonometry, here's the cosine graph from 0 to 2 pi. And there's two places where it will equal 0. One is going to be when t equals pi over 2. And the other one is going to be when t equals 3 pi over 2. So that's when the derivative of the x function is equal to 0. So that's when it ceases to go either left or right. And so if you go back to the graph, and it's this, hold on, let me just go back to the graph. So if you go back to the graph, then basically when it gets to this pinnacle right here, this top point, then the x can no longer go to the right. It has to stop for a moment, and then it has to go back. So this is a place where the dx dt is equal to 0. And the other place would be way over here on the left. Okay, so we have those. The pi over 2 and 3 pi over 2 for the derivative of the x part. Then for the y part, let me just clean this up a little bit. So the derivative of the y function, dy dt, so first of all use the power rule, so bring the 2 down in front and multiply, and then it's going to be cosine of 2t. And then the derivative of cosine is negative sine of 2t. And then the chain rule says also multiply that by 2. And when you set it equal to 0, then you could have the negative 4 in front because we've got the 2 times 2 and a negative. And then we would have a cosine of 2t, and we would have a sine of 2t. So when you set the cosine of 2t equal to 0, well, we just did that, and we got pi over 2 and 3 pi over 2, except this is going to say 2t equals pi over 2, 2t equals 3 pi over 2. And then divide both of those by 2, so we would get pi over 4, and then also 3 pi over 4. So those are places where the dy dt equals 0, so that's where it ceases to go up or down. So it either gets to the top or the bottom. I'm just going to test that theory by looking at pi over 4. So if you look at the graph and use pi over 4, so then I need to type in pi divided by 4. So that is a place where the y value, because it had been here, so the y value is getting smaller and smaller, then it doesn't change just for a moment, as you can see as it turns red, and then the y values start increasing again. So that seems to be correct. And then for the very last part, and that is, I still need to put this one equal to 0. So the sine of 2t equals 0. If you look at the basic sine graph, it looks like this. And so it equals 0 at 0 and pi and 2 pi. And like with the last one, we need to set all of those equal to 2t, or in other words, divide all of them by 2. So then we would get t equals 0, t equals pi over 2, and t equals 3 pi over 2. And then notice that there is one other interesting thing to notice, is that pi over 2 shows up in both answers, and so does 3 pi over 2. So both derivatives equal 0 when t is pi over 2. And that is those endpoints. So if I type in a pi divided by 2, then that should be, yes, that endpoint. So at that point, the y's can't get any bigger, the x's can't get any bigger, and so then it has to then back down and to the left. And then the same thing would happen at 3 pi over 2 when it gets to that point way over on the left.